Right.
From the earliest point in humankind, we've been able to look up and dream about the moon. Now it's time to settle there. The moon gives us infinite resources such as tritium for our reactors, more iron than we can imagine, making steel the cheapest building substance, and water from ice. New technology such as rockets to make space travel cheaper, possibilities of a Dyson swarm for infinite energy, and a new race to get the best moon technology to promote a whole new part of the economy, and a race to continue the galactic rule. With all these great reasons to why haven't we? With it being $50 billion and other problems being in the minds of government heads and taking 10 years to complete, it's hard to get everybody on board. But talks about lunar landers, habitation pods, and a whole new lunar colony is coming up next. Here we have phase 1, which was actually done 50 years ago, which is exploration and scouting of the moon, including gathering resources, information, and making further plans. This phase was already done with the original Apollo 11, pictured here, and the black and white. As said in NASA's article about Apollo 11, flight objectives included scientific exploration by the lunar module, deployment of a television camera to transmit signals from Earth, deployment of a solar wind comparison experiment, seismic experiment package, and a laser ranging retroreflector. Throughout this phase, we find a few things like landing spots, metallic makeup of the moon. With this information, NASA began to work on their next lunar mission, the Orion project. Though there was Apollo 12 to 17, which all landed on the moon with the exception of 13, none were manned and none set up permanent infrastructure on the moon. The Orion project solves these issues. However, NASA isn't the only company with lunar intentions. Moon Express, pictured in the colored picture on the right, is another company looking at the moon with money on the mind. By sending robotic assemblers and miners, they plan on setting up the first robotic lunar colony for the sole purpose of production of many resources and profit. Regardless of who it is the first to get there, and whether it's robotic or not, first a few things need to happen. Now, a big portion of the original moon landing's research was to determine the proper landing spot, as the moon landing presented many problems. The Apollo 11 only had 3 low-power thrusters, which wouldn't allow it to untip itself if it had landed on a rock incorrectly. The moon has lower gravity as well as rough terrain from years of asteroid impact. This makes landing also difficult. With this information, physicists from Space.com theorized it would be a better idea to land in one of the moon's lava tunnels. This idea allows protection from space dust, ionizing radiation from the sun, and asteroid impacts. Reflecting light into the tunnel allows us light and power so we can start working on mining the moon right from inside the tunnel. Making sure the tunnel is near to one of the poles is also necessary because the poles can provide a longer and more consistent lunar day cycle. Once the first lander is landed in the lunar tunnel, and miners can start extracting the surrounding resources for building the first habitat. At this point, most of the structures on the moon are standalone refineries and solar collectors made to assist the robotic or manned mission on their next structure, which is this livable habitat. With people permanently able to be stationed to end the lunar day, where sunlight is available constantly, this base first needs a few resources. Firstly, the 3 human fundamentals: food, air, and water. Luckily, this is explained in the article earlier by David Leonard in his interview with NASA Director Pascal Lee. Exploring high-latitude pits on the moon might therefore offer an additional opportunity to harvest water on our lunar neighbor. With lunar ice, we can break down into oxygen used for machinery, plants, and of course people, and hydrogen, which can be talked about later. With other elements broken down from the lunar surface, we can create drinkable water and breathable oxygen. And with those 2 things, we can grow our own food. Another key component to growing our own food is sunlight, which is a problem on the moon where the lunar cycle lasts 29 days. About 14.5 days of sunlight, about 14.5 days of complete darkness. Since we landed near the poles, we have what NASA calls eternal peaks. In their 2020 press release, they describe them as areas of the moon that reach high enough to get consistent sunlight, at 70% sunlight or 20 days in the winter months, and 100% sunlight during the summer months. This allows us to get consistent power as well as light for plant growth. This plant growth not only brings us food, but recycles oxygen, carbon dioxide, and other organic matter in the habitat. The habitat chamber being set up, we're ready to slowly stop our supply chain from Earth and start exporting on our own. Our first export is going to be water. Now, closer to a lunar compound with a central base of operations, and other smaller buildings that produce their own resources, so we can continue with minimal import from Earth. Since we pivot from phase 1 of getting our resources from Earth to phase 3 of self-sufficiency, we enter phase 2 where we see our first export, water. Now there may be water on Earth, but the refiners can break down the water into oxygen that we need for earlier, and hydrogen, which can be now used for rocket fuel. Creating rockets on the moon and then fueling them using lunar hydrogen is akin to the American colony sending their first homemade ship of gold and corn to the British. Nevertheless, it's a huge step in the self-sufficient lunar colony. To send a ship, you need a dock, and to send a rocket, you need a station where we can create, repair, and refuel ships to travel back to Earth, further into space for deep space exploration, or Mars and Europa for next colonies is our next step. Our next step being the orbital outpost. Now, close to our own International Space Station, but being constructed on the moon and launched into lunar orbit, the outpost serves many purposes. The outpost can be the place of lunar experiments and technology development, as well as stated before, as its primary use of refueling the station for shipments back to Earth, as well as shipping around the moon for more colonies. It can also ship more resources around, so companies can fuel their exports, and we can start the lunar economy. With companies and countries cheaply exporting from the moon with enormous profit, as well as stock, we call for phase 2, the lunar economy. As many other countries and companies see other profit, they will start doing it themselves, which will increase incoming material and cheaper rocket fuel. We can start progress on the next megastructures, such as the Dyson Swarm, a potential power source, such as it said in Stuart Armstrong's paper, Expanding the Universe. Now, because of the available material, we can start these cheap megastructures, and this starts a snowball effect. Cheap megastructures see massive results, see cheap resources, see cheap advancements, see cheap energy, and sees more space colonization. Slowly, more opportunistic look is on the moon for a better life and a new land of opportunity. This calls for history to repeat itself. Just as before, when America broke away from Britain so long ago to become the land of opportunity, the moon colony will become its own permanent population with its own problems. History repeats itself, and in America and Britain analogy, this is where America declares its own independence. Slowly, engineers and businessmen aren't the only people who are coming to this new life. It's entertainment, opportunistic people looking to make it big. Eventually, people living there will sustain their own population by creating more. People born on the moon mark the final step in our self-sufficient lunar colony. From now on, we have our own new civilization, interplanetary. And that's the end. There we go.